Okay, so this is 2014 number 3 with the graph. I'm just going to draw the graph. Okay, that's not great, but you get the idea. So I'm just going to label some key points. This is -5, 2. This is -3, 0. This is 0, 4. This is 2, 0. And then we have this other point down here, which is 4, -4. Okay, so the first part of the question asks us to find, and we know that g of x equals the integral from -3 to x of f of t dt. So that means that they want us to start any kind of value for g of x at -3 when you're looking to find the integral, which is the first part. So we want g of 3. Sorry, it's a little noisy. So g of 3, that's the integral from -3 to 3 of f of t dt. So what I do is I find the areas of, I find these areas, right? So the first one is a triangle. Well, they're both triangles. But the first one is going to be, we know that the distance, so it's 1/2. The height is 4. And the base is from here to here, which is 5. Right? So that would be, the area of that would be 10. This guy, oh, I should actually fix this because this is not, I didn't draw that 100% correctly, because really we don't want that. We want here when x is 3. This is the area we want. So I need to find what the y value is there so I know what the height of that triangle is. So what I need to do is, so I'm going to do this in blue. So I need this y value. So the slope of that line, we're going to need the slope later. The slope of that line I know I can get from doing 4 over 2, 4 over -2, which is -2. And then so the equation of that line would be -2x plus 4, because the y-intercept is 4. And so at x equals 3, the y value is -2. Okay. So the area of that triangle is 1/2. The base is 1 because I'm going from here to here. And the height is now 2. Well, a -2, I can say. So that would be -1. So the area, the total area would be 10 minus 1, which is 9. So that would be the answer to part A. And we're going to need that again too. So this is g of 3. Okay, so that's part A. Part B says, on what intervals contained between -5 and 4 is the graph both increasing and concave down. So again, I'm going to sketch this graph. Okay, so this is 5, 0. I'm sorry, this is not 5. This is -3 over here. That's 5, because all we need are x values. This is 2. Okay, so what you want to remember is that g prime of x equals f of x. The derivative of g is f, because g is equal to the integral of f. Okay, so think about that for a moment. If you need to pause it, you can. So what I need to do is I need to look for when, so this graph, this is f. That means that this is the derivative of g I'm looking at. So I know that g is increasing when the derivative is positive. So g is increasing from -5 to -3, -3 to 2. Now I need to know, when is it concave down? Well, I know it's concave down. G is concave down, right, when the second derivative is negative, and that means that the first derivative, when the second derivative is negative, so that means when the first derivative is decreasing. So G is concave down from -5 to -3, right? -5 to -3 and 0 to 2. So where is the overlap? Well, the overlap, so G must be concave down and increasing on -5 to -3 and 0 to 2, because F is decreasing and positive on those intervals. And that's all you have to say. You just have to say, like, what was your thought process? My thought process was I needed to figure out where F was decreasing and positive. You can just write that. That's fine. And I would have this somewhere as well. Okay. That's part C. Part C is asking us, it says h of x is g of x over 5x, and they want us to find h prime of 3. Now this is going back to those kind of chart problems we did a long time ago, because I need to find the derivative using, I have to use the quotient rule here. So g prime of 3 times 5x, or 5 times, you know, at first I'll just do h prime of x, and then we'll fill it in with 3's so that you can follow it maybe a little better. So that would be g prime of x times 5x minus 5 times g of x all over 25x squared. And now I'm ready to fill in of 3. So g prime of 3 times 15 minus 5 times g of 3 all over 25 times 9. Now, if you're thinking to yourself, what is g prime of 3 and g of 3? Well, we actually found g of 3 a while ago. G of 3 was 9. We did that in part A. How do I find g prime of 3? Well, g prime of 3 is the slope at 3. So g prime of 3 is the slope I'm sorry, g prime of 3 is not the slope. G prime of 3 is the value, is f of 3, because we know that g prime of x equals f of x. So f of 3 is, we found that, that was -2. Sorry about that. Okay. So h prime of 3 equals, so g prime of 3 is -2 times 15 minus 5 times 9 all over 225. And you end up getting -75 over 225, which is -1/3. Okay, that's part C. Okay, part D, along the same lines of part C in the sense that you have to remember your derivative rules. So they tell you p of x is f of x squared minus x. Don't think too hard about this. If you get caught up in the notation, or if you get caught up like with, I don't know what that means, It's okay. Just take a deep breath and just take the derivative because they're asking you for the slope of the tangent line at x equals 1, negative 1. So when in doubt, you just take the derivative. Now you know how to take derivatives with this kind of notation. We just did it in the previous problem. So the derivative is, now remember, this is the chain rule, right? The derivative of the outside times the derivative of the inside. So p prime of negative 1 is going to be f prime of negative 1 squared is 1, 1 minus negative 1 is 2, times 2 times negative 1 is negative 2, so negative 3. So I need to find out what f prime of 2 is. Sorry, that's the slope at the graph. So f prime of 2 is the slope at x equals 2 on the graph. So if I go back and find the slope at 2, well, we know what it is. We found it for, remember, we had y equals negative 2x plus 4. So this is what I need. So f prime of 2 is negative 2. So f prime of negative 1 is negative 2 times negative 3, which is 6. And that is 2014, number 3.